space is vast. Imagine the darkest night you've ever seen, then multiply that darkness by infinity. Now picture a planet like our Earth, hurtling through that darkness. No sun to warm it, no nearby stars to provide even a glimmer of light. This is the reality of a rogue planet, a cosmic orphan drifting alone through the interstellar void. These rogue planets, once thought to be rare, are now believed to be incredibly common. They wander through the galaxy, unseen nomads in the vast cosmic desert. Their existence challenges our understanding of planetary systems and raises tantalizing questions about the potential for life in the universe's most unexpected corners. Rogue planets, also known as interstellar planets, are celestial objects that share the characteristics of planets but lack a host star. These mysterious wanderers drift through the cosmos, untethered to any solar system. They are gravitational orphans, ejected from their stellar nurseries and cast adrift in the Milky Way. Without the warmth and light of a star, they traverse the cold, dark expanse of space. While we are still discovering the true extent of their numbers, astronomers estimate that billions, possibly even trillions of these rogue planets exist in our galaxy alone. These planets could be more common than the stars themselves. Imagine our solar system with its familiar planets orbiting the sun. Each planet follows a predictable path, held in place by the sun's gravity. Rogue planets were once part of systems like ours, but were flung out due to gravitational interactions with other planets or passing stars. These violent encounters can send a planet hurtling into the void. Now they roam the galaxy as solitary wanderers, their surfaces locked in a perpetual deep freeze. Without a star to provide heat, these planets are often icy and desolate, their environments harsh and unforgiving. Rogue planets form like any other planet, born from the swirling disks of gas and dust that surround young stars. These disks are the remnants of the stellar nursery, a chaotic mix of particles and gases that coalesce under the force of gravity. These protoplanetary disks are the chaotic nurseries of planetary systems, where gravity pulls material together to form planets of various sizes. Over millions of years, these materials collide and merge, gradually building up the mass needed to form a planet. However, the story of a rogue planet takes a dramatic turn when it is violently ejected from its birthplace. This ejection is not a gentle process. It is a cataclysmic event that sends the planet hurtling into the vast emptiness of space. Gravitational interactions within a young planetary system can be like a cosmic game of billiards. Each planet's gravity influences the others, creating a dynamic and ever-changing environment. As planets form and their orbits shift, they can tug on each other with their gravity. These gravitational tugs can alter orbits, sometimes leading to close encounters that can dramatically change a planet's trajectory. Sometimes these interactions become so intense that a planet is kicked out of the system entirely, flung into the interstellar void like a stone from a slingshot. This rogue planet then drifts through the galaxy, a lonely wanderer in the vast cosmic ocean, forever separated from its star and sibling planets. Life on a rogue planet, if it exists, would face extraordinary challenges. These planets, wandering the cosmos without a parent star, are isolated and desolate. The conditions are harsh and unforgiving, making survival a daunting task for any form of life. Without a star to provide warmth and light, these planets are incredibly cold, with surface temperatures plummeting to near absolute zero. The absence of solar energy means that any heat must come from within the planet itself, perhaps from residual geothermal activity or radioactive decay. Their surfaces would be shrouded in perpetual darkness, illuminated only by the faint glow of distant stars and galaxies. This dim light is insufficient to support most known forms of life, which rely on sunlight for energy. Imagine a world where the air itself freezes, forming a layer of solid nitrogen or even hydrogen ice on the surface. The atmosphere, if it exists, would be thin and composed of gases that can freeze solid in the extreme cold. Oceans, if they exist, would be vast expanses of ice, potentially kilometers deep. These frozen seas would be inhospitable to most forms of life as we know it, with only the possibility of extremophiles surviving in such conditions. The lack of sunlight would make photosynthesis impossible, ruling out the familiar plant life that forms the base of most ecosystems on Earth. Any life forms would need to find alternative energy sources, perhaps relying on chemical reactions or geothermal heat to sustain themselves in this frozen, dark world. Despite the harsh conditions, the possibility of life on rogue planets is a tantalizing question that scientists are eager to explore. Life, as we know it, is incredibly adaptable. On Earth, we find organisms thriving in extreme environments like deep-sea hydrothermal vents, where sunlight never reaches, and in the frigid, dry valleys of Antarctica. Could similar extremophiles exist on rogue planets, perhaps finding warmth and energy from internal geological processes like volcanic activity or tidal heating? Could life have evolved in ways we can't even imagine, sustained by forms of energy completely alien to our understanding? Detecting rogue planets is a formidable task. Since they emit very little light and are not bound to a star, traditional methods of planet detection, which rely on observing the wobble or dimming of a star caused by an orbiting planet, are ineffective. Instead, astronomers use a technique called gravitational microlensing to uncover these hidden worlds. Gravitational microlensing relies on the bending of light by massive objects. As a rogue planet passes in front of a distant star, its gravity acts like a lens, magnifying the star's light. This temporary brightening of the star reveals the presence of the otherwise invisible rogue planet. The discovery of rogue planets has profound implications for our understanding of the universe. It suggests that planetary systems are dynamic and ever-changing, with planets being ejected and potentially even captured by other stars. It also expands the potential habitats for life beyond the traditional habitable zones around stars. Future missions, equipped with advanced telescopes and instruments, could study rogue planets in greater detail, analyzing their atmospheres and searching for signs of life. Perhaps one day, we might even send robotic probes to explore these enigmatic worlds up close, unraveling the mysteries they hold. Rogue planets, once a mere theoretical concept, are now a confirmed reality, challenging our assumptions about the universe and expanding our horizons in the search for life beyond Earth. These dark, solitary wanderers hold clues to the chaotic early days of planetary systems and the remarkable resilience of nature. As we continue to explore the cosmos, uncovering the secrets of these cosmic orphans, we gain a deeper appreciation for the vastness and diversity of the universe and the endless possibilities it holds. The story of rogue planets is a reminder that even in the darkest corners of space, nature finds a way to surprise and inspire us.